Okay, so we'll look at the trigonometry tutorial sheet. This is tutorial sheet 6. So there are plenty of questions that we need to answer. Okay, so we'll start with the basics of trigonometry. I hope you've watched the video about the introduction to trigonometry. Okay, so we'll start by filling in this table where we need to understand the sine, the cosine, the tan, the cotangent, sec, and cosecant. So I would advise you basically watch the introduction so that you know the special triangles or the special angles from the those triangles. So I can maybe just give you a quick recap. So usually I was actually exposed to degrees before radians, so I usually think in degrees. Okay, so 45, 45, and then that's a 90, so that is a 1 1, and then this is root of 2, and then the other triangle is a 30 60. If you think about it in terms of radians, it's pi over 6 pi over 3. Okay, so something like that. And then here you have like a 90, you can have a 30 there, you can have a 60 there. So I know that sine half is actually equal to 30 degrees. So that tells me that from SOHCAHTOA I know that sine is actually opposite over, what am I doing? It's actually sine 30. What? Sine 30 is equal to 1 over 2, which tells us that is opposite over hypotenuse. So the opposite of 30 should be a 1. So we have a 1 there. The hypotenuse is a 2. Then that is like the root of 3 by using Pythagoras theorem. So these are the two major triangles we're going to focus on to come up with a special angles. So SOHCAHTOA tells us what we're supposed to do. So if you look at any given angle, you need to look at what the ratios are saying. So if you look at sine, for example, sine of any angle is equal to the opposite over the hypotenuse of that triangle. The hypotenuse is the longest side in the triangle where the 90 degrees is pointing. Adjacent is the side attached to that angle. So for example, if you look at the 30 there, the side that is adjacent to 30 is this side. Okay, we ignore the hypotenuse because we know this is the origin hypotenuse. So the other side is adjacent to that angle. So that means that in a case where you're trying to find the cosine of 30, if you look at the triangle, according to SOHCAHTOA, the trig ratios are telling us it's adjacent over hypotenuse. So the adjacent is that side, and then the hypotenuse still remains to be 2. Okay, so this will be very useful as we get to proceed. I can also give you an example of sine 45. Sine 45 from the other triangle, the opposite is a 1. The hypotenuse is root of 2. This is a case where even cos is equal to is the same. Cos 45 as well. The adjacent is still a 1, and then the hypotenuse is still the same. So cosine 45 is equal to sine 45. So we'll apply this as we answer our few in that table. Now convert to radians. Now to just give you an idea and just to understand a few things about radians, if you want to make your conversions from radians to degrees easier, think of the pi to be equal to 180. So that means that if you have pi over 6 and then you can't basically understand or identify it as a special angle, or maybe you're more exposed to the degrees, just substitute. The pi is a 180 over 6, and then 6 into 18 is like 3 times, and then you have like a 30. So you can clearly see to say, okay, pi over 6 actually means 30 degrees, and then if you've got pi over 3, it means 60 degrees. That way you'll be able to understand. So if you have pi over 4, for example, you should be able to tell that that's equal to 45 degrees. So you'll be able to identify these special angles easily. Okay, so let's try to see what we can do with what we have. The other thing that I need you to know before we actually get to answer this question is the issue of finding the answers. Okay, so know that all the three are positive in the first quadrant. In the second quadrant, sine is positive. There we have tan. So all students take coffee, that can help you remember. You understand why I'm talking about this? Okay, let's start. Okay, so the first part is 1 to find sine. Actually, the other thing that can also help us are also graphs. So let me also try to show you the graphs. The graphs are also very useful. Graphs can also help you remember. So I know that sine actually starts from 0, like that. Okay. So know that this is actually 0, this is 90, that is 180, and then that is 270, and then that is 360. And then know that the amplitude there is a 1, this is -1. So this can give you values as well. So you know that sine 0 is actually a 0, sine 90 is a 1, sine 180 is a 0, sine 270 is -1, sine 360 is a 0. That is also very helpful. Now for the cosine, it starts from 1 and moves like this. So it will start from the 1 there, it will cut at 90, and then 10 from... wait. Okay, let me do this. Let me just do another graph. Okay, so to avoid the confusion, so it moves like this. That's a funny part. So it starts at the 1. So at 90 it cuts at 0, and then at -1 it's 180, and then at 270 it gets back to 0, and then at 360 it gets back to a 1. This is how unique the cosine is. Of course, I don't want to talk about the tan, it's just complicated. So these graphs will be very useful as we proceed. So already from the graph we're able to see that sine 0 is actually just a 0, because the graph actually starts from this point like this. And then pi over 4. Pi over 4, if you don't know what pi over 4 is, you are thinking in degrees. Pi over 4 is 3. The pi I said put a 180, so 180 divided by 4. So pi over 4, if you divide the 4 into 180, it's 45. So 45, we've got that special triangle there. So what is sine 45? I hope you've not forgotten. I actually removed that. So sine 45 is actually a triangle where you've got two sides equal. 45, 45. This is root of 2. That is a 1 and a 1. So it's 1 over root 2. Because I know sine is opposite. So opposite is the 1 over the hypotenuse, which is root of 2. Okay, don't forget that. Then pi over 2 is a 90. Pi over 2 is a 90. You can easily tell that. So sine 90, if you look at the graph, at that point, 90 degrees is actually equal to a 1. So 1. Now we have 3 pi over 4. What is 3 pi over 4? So 3 pi over 4. You can actually pull out the pi over 4. So you actually know that the pi over 4 is a 45. So 45 times 3. So it will be 90 plus 45. So in other terms, if I bring back the quadrants there, so if we have 3 45s, the first 45 will be there, 45 gives us 90, and then you have an extra 45 now in this quadrant, 45. So if that is 45, the angle that helps us to find the answer is the angle that is made between the x-axis and where the angle has reached. So this is the 45 as well. If we move from the 90 here, we find that this is the 45. So that's the 45 we're interested in. Okay, so now you know that from the first quadrant, sine is all are positive. In the second quadrant, sine is positive. So if we are saying in the first quadrant, sine 45, which is like pi over 4, or 1 over root of 2, since it is sine is also positive in the second quadrant, the answer will still be the same because it is making 45 with the x-axis. Okay, so the answer will still be a positive 1 over root of 2. Okay, now if it was if it had made a 45 with the That means if it was like 5 times 1 2 3 4 5, if it was here, it would be a negative, because this is a case, this is where tan is positive, so it would be a negative 1 over root of 2, but the value still remains the same. Okay, so you're now understanding how you find these angles from different quadrants. So the calculator actually gives you answers only from 0, between 0 and 90, and then it's up to you now to find the angles in the other quadrants. Okay, and then we have 5 pi over 6. So pull out the 5, you remain with pi over 6. So I told you what pi over 6 is. 180 divided by 6 is 30. So this is the 30. So 30 is what we are having there. So 5 times 30 is what? 5 times 30 gives you 150 degrees. So why is 150? 150 is in this quadrant. So 150 is 30 before 180. So there's a difference of 30 between 150 and 180. So I've told you that for you to find the other angle, you need to measure the difference between that actual angle and the x-axis. If you are in this quadrant, you need to find the difference there. If you're in this quadrant, you need to find the difference there. If you're in this quadrant, the difference with the x-axis. That's how you find the values. So 5 pi over 6 is 150. So there's a difference of 30 from 180. So we'll assume we are finding 30. Now this is still going to be positive because sine is positive in the second quadrant. Okay, so what therefore do we have? Sine 30 is also coming from a special triangle, which is a very common one. Sine 30 is basically 1 over 2. So sine pi over 6 is 1 over 2 for your information. Okay, it's 1 over 2 for your own information. Now in the second quadrant, sine still remains positive, so the answer will still be 1 over 2. If we were making a 30 after 180, meaning that we are in the third quadrant where tan is positive, sine would be negative, so it would be negative 1 over 2. Okay, let's go to the negatives now and see what we're going to have. So by the way, after we are done with the first row of sine there, the other calculations that we're going to be making will be very easy, as you actually just get to observe. So I just need to connect this thing again to the charger. This keep on opening. So you can actually pause the video and just try out what's coming. Okay, we can now continue. Sorry for that. Okay, so we're going to the negative parts now. So for the negative, the first one we have is negative pi over 3. Negative pi over 3. So what do you know about negative pi over 3? So ignore the negative. Pi over 3, I told you it's 60 degrees, right? If you divide 180 by 3, it's 60. So you go back to your quadrants. So if you are going to the negative direction, because it's negative 60, you are going to the negative direction. So you are making an angle of 60 degrees with the x-axis. So whenever you are going the clockwise way from the 0 degrees, that is whenever you're just going clockwise, actually it's negative angles. So you actually take them as you take the positive ones. So you know that in a normal way, the 60 degrees in the positive x-axis, or in the first quadrant, sine 60 is basically another special angle, which I showed you. Well, it's not here anymore. So this triangle is very useful, very important actually. So 30, 60. So 1 2 root of 3. So sine 60, we know that Swakatua tells us for the sine it's opposite over hypotenuse, right? So the opposite is root of 3, the hypotenuse is 2, so root of 3 over 2. So root of 3 over 2. Now, which quadrant are we in? So all students take coffee. So we are in the fourth quadrant. Now in the fourth quadrant, sine is negative. Sine is only positive in this quadrant and the first quadrant. Okay? So therefore it's a negative answer. So it will be negative root 3 over 2. The next one is kind of like we've only like doubled, because if you look at what we have actually, if you look at what we have like negative 2, and then we have like pi over 3. Pi over 3 is still 60. So if you multiply times 2 is like 120. So 120 means now you've bypassed the 90 and then you are here. So what magnitude are we talking about there? So 120, because this is 60 times 2, 120. Now negative 120, so we're moving from 0 and then we've reached now negative 120. So again we need to find the difference with the x-axis. So how much do we need to add for us to get to 90 from where we are at 120? So this is actually going to be negative 180, because we've rotated this way. So the difference from 120 to 180 is still 60. So it's an angle of 60 there. So now ask ourselves, is sine actually positive in this quadrant? No, it is negative. So it will still be negative root 3 over 2. I just hope we'll have enough space. Let me write better, negative root 3 over 2. And then negative pi, that means just negative 180. So you've moved all the way the negative way up to 180 here. So what's the expected answer when you have negative 180? The first question you want to ask yourself is, what value is sine 180? So sine 180 from the graph, what did we see? We've actually removed the graph already. So the graph for sine, we said it starts from 0 and moves like that. So 0, 90, 180. So 180 is 0. So if you grab your calculator and just try it as well, even if it's negative, you're still expected to get a 0. So you have a 0 there. And then we have negative 3 pi over 2 again. Negative 3 pi over 2. So negative 3 pi over 2. You still can't understand that value. So the simpler way of understanding that faster is putting out the coefficients, so that you have pi over 2. Pi over 2 tells you that is 90. That is 90. So you are moving 3 times in the negative way. So if you've got 3 90s, where are you going to be? So this would be the first 90, second 90, giving you 180, and then the third one there in the negative way. So if you add them, 90 plus 90, 180 plus another 90, that would be like 270. So ask yourself, 270, negative 270. What is the value of sine 270 in a normal way? Go back the graph like this. So that's the way sine moves. So 0, 90, 180, 270. So 270 is like what? Negative 1. So is it the same for the negative? If you say sine of negative 270, so this one is negative. Sine of negative 270 is expected to be a positive result. So we have a positive one there. So somehow this is matching up with 90 there. So negative 270 as happens to be found at the point where we have 90 degrees, so it is also a 1. Okay, so we've filled in the first part. Everything else will be easy for you to actually do. So I'll start with the first part, and then I'll go down, I'll finish the column, and then just and so on and so forth. So for the first one, negative 3 pi over 2 that we're from dealing with, we found that that is like a negative 270, right? Negative 270, which means that we've moved 3 90s in the negative way. So it is matching up with 90. So that will be the easiest way of thinking about it. Okay? So what is cosine of 90? So the cosine graph, I said it starts from where? It starts from 1. Right? Now cosine 90 happens to be a 0. So we expect that if we are to even punch on the calculator again, cosine of negative 270 as well, it's also expected to be a 0. So it will be a 0. Tan 90 now. We are on tan 90. So the easiest way of thinking about this is if you have got sine and cosine, you can actually just know that tan theta is going to be dividing them. So sine theta over cosine theta from identities. So now look at the cosine. The cosine there is like a 0, right? So you can't divide by a 0. So it becomes undefined, right? It becomes undefined. And you can grab your calculator and try it out. Tan. Okay. So if you're actually enjoying this video, you can actually have access to the full trigonometric solutions that will allow you to understand the topic fully. So the question 1 is there, the question 2 is there, the question 3 there, the question 4. Identities are also there. As you can see, question 6 and 7 are based on identities. Double angles are also there. Okay. So you'll be able to understand the half angle principles as well, looking at question 4. And then as we go to question 8, you'll also be able to understand how to go about it, how to solve trigonometric equations. Question 9 is also there, how to answer more equations. Question 10 dealing with sketching. Question 11 dealing with sketching. Question 12 dealing with sketching. Question 13 sketching as well. And then you also understand how to determine or evaluate these trigonometric kind of expressions, looking at question 14, 15, and also 16 as well. So you can have access to all these solutions by just registering. So you can visit our site, the link is in the description. From there you can also learn the topic from scratch, each basic concept step by step, and also access the solutions to this entire tutorial sheet. Of 90 or negative 270, it should be undefined. Okay, or math error. So we can't find that because we can't divide by 0. Now cotangent that you have on the bottom, without wasting much of your time, you can think of it as 1 over tan theta. Okay, or cosine over sine from the identities. Cosine theta over sine theta. Now if you look at the values that we have, I think in that way you'll be able to find it. Cosine theta is 0, sine theta is a 1. So 0 divided by that, so this is a 0. So at least you're able to find that. But don't choose tan theta because you won't be able to find, so it's better. Of course, in the introduction video, I've explained how 1 over tan theta becomes cosine theta over sine theta. it's a reciprocal of this. So, and then sec theta means 1 over cosine theta, that is equal to secant. And then cosecant is 1 over sine, 1 over. So this one shouldn't be a struggle, just look at the value that you found. So 1 over cosine of theta has been found to be a 0. So if it is a 0, you can't divide it into a 1, so it's undefined as well. Then cosecant, sine was a 1, so it will be 1 over 1, which is just a 1. We go to the next one. We have negative pi. Negative pi is equivalent to positive pi, which is equivalent to 180 degrees. Okay, if you want to think in degrees. So what is cosine 180? If you've forgotten, got the graph. What is cosine 180? Cosine 180 is there, negative 1. Negative 1. What is tan theta? So that would be sine over cosine. So 0 divided by negative 1, it's a 0. Cotangent theta, it would be 1 over tan. So 1 over 0 is undefined. Well, we can think about it in a different way. Cosine divided by sine. Cosine is negative 1, sine is, so it's still undefined. Secant, 1 over cosine. Our cosine is negative 1, so it will be negative 1. Then cosecant 1 over theta, which is a 0, so it's undefined. We are back. Negative 2 pi over 3. So this one actually gave us a value of what's to get negative root of 3 over 2. So it gave us like 60. Gave us a 120. Gave us a negative 120. Yes, give us a negative 120. I remember. So in case you've forgotten what we've done so far, what we did is we put out the 2, and then we remained with negative pi over 3. Now negative pi over 3, pi put there 180 divided by 3 gave us 60. So we made 2 60s. So 60 gave us 120. So it bypassed the negative 90 and came somewhere here. So we had to find the angle between the x-axis and the angle itself. So it was a difference of 60. So we're now looking at the 60 in this quadrant, which is first, second, and third. So here tan is expected to be a positive value. Okay. So cosine of 60 from the first quadrant, we know that it's 1 over 2 if you got the special triangle. Cosine 60 is, the adjacent is a 1, the hypotenuse is a 2. So cosine of 60 is equal to 1 over 2, which is actually equal to sine, which is equal to sine 30. So cosine 60, so all students take coffee. So in this quadrant, cosine is only positive in the first and in the last quadrant. So in this quadrant, it's going to be negative as well. So it will be negative 1 over 2. And then tan of that, divide the sine by the cosine. As simple as that is. So for the sine, we have negative root 3 over 2. And then we are trying to divide by the cosine, which is like negative 1 over 2. So you can multiply by reciprocal, which is like 2 over negative 1. So the 2's can like go away. And then you have like a positive root of 3. Cotangent is 1 over that, so it will be 1 over the answer there. 1 over cosine gives a secant, so it will be like a reciprocal of that, so it will be like negative 2. And then 1 over sine is like, so it will be 2, the reciprocal of that will be 2 root of 3. Okay. And then we are on the part for negative pi over 3. Now negative pi over 3 is basically equal to what? Negative 180 over 3. So I'm just trying to remind you that is like negative 60. So negative 60 is like 60 degrees with the positive x-axis below. So this is the fourth quadrant. So cosine is positive. All students take coffee. Cosine is positive, so have a positive value. Now, what is cosine 60? Cosine 60 is 1 over 2, so it will be a positive 1 over 2. Tangent, divide sine by the cosine, so negative root of 3, again, negative root of 3 over 2, divided by half again. In other terms, you multiply by the reciprocal. So the 2's will like divide, and then you end up remaining with negative root of what? Negative root of 3. And then for the cotangent, it will be 1 over that, so it will be 1 over negative root of 3. The second, it will be 1 over the cosine. The cosine was half, so 1 over half is like the reciprocal, which is like 2. 1 over sine will be the reciprocal as well, it will be 2, and then negative 3. Okay, we can fill in the 0 now. Cosine 0, the cosine graph I said starts at 1, so cosine 0 is equal to 1. Tangent is going to be sine over cosine, so 0 divided by 1 is 0. Cotangent is 1 over 0, or 1 over tangent, which is in this case would be undefined. You can think about it another way, cosine theta over sine theta. So cosine theta is 1, and then sine theta is 0. Yes. So cosine is 1, so that used to be undefined anyway. Second, 1 over cosine. The cosine is a 1, so it will be 1. Cosecant 1 over sine, so 1 over 0 is undefined. We are now back on the 45. Pi over 4 is 180 divided by 445. So I hope you've not forgotten the 45 triangle. It's a very simple triangle. This is a case where two sides are equal. The hypotenuse is root of 2. So we have 45, 45. So 45, 45. 1, 1, root of 2. So if you're dealing with cosine, I said sine 45 and cosine 45 are the same. So even if you look at the adjacent over the hypotenuse, to be 1 over root of 2 as well. And then tan theta, if you divide them, this is actually going to be equal to 1, even if you use the trig ratios. They are equal. Since they are equal, it will be the same. And then cotangent will be 1 over 1, which is a 1. Second, 1 over cosine. Cosine was 1 over root of 2, so the reciprocal will be root of 2. And then cosecant as well will be a reciprocal root of 2. We're now on pi over 2, which is 90. So cosine 90 is like a 0. If you look at the graph, it starts from a 1. So at 90 is equal to 0. And then tan of that is sine over cosine. So 1 over pi by 0 is undefined. Cotangent is cosine over sine. So it's a 0. And then secant 1 over cosine. So cosine is like a 0, so it's undefined. 1 over sine for cosecant, it's a 1. And then we have 3 pi over 4. 3 times 45 degrees. 3 times 45 degrees. Which quadrant are we falling in now? If you look at the 45 coming 3 times. So 45, 45 would give us a 90, and then we have an extra 45 there. So we are interested in the difference between the angle and the x-axis, so which will still be a 45. So which quadrant are we in? Second quadrant. So here sine is positive, the rest are negatives. So let's see what we're going to have. So cosine of 45, cosine of 45 is actually 1 over root of 2. Now we're in the second quadrant, so it will be negative 1 over root of 2. Tangent here we said it's actually equal to tan 45 is actually equal to 1. Now in the second quadrant it's negative, so it's negative 1. Cotangent is 1 over that, so it will be negative 1. Secant is be 1 over cosine, which will be the reciprocal, negative root of 2. Cosecant to be a positive root of 2. So what I'm trying to say is, if you have 1 being divided by a fraction, it will be reciprocal, meaning that it will be root of 2 over 1. That's how I'm getting these results for the last part. You just like swap whatever you add. And then finally on the last part, pi over 6 we did establish to say that is like equal to 30. And then after plugging 5 times 30, we have like 5 times 30 is like what, 150. So we have a difference of like a 30 with, so 150 somewhere there with a difference of 30 with the x-axis, because if this is 150, for us to make it 180 we're remaining with an extra 30. So we're interested in the difference with the x-axis, so it will be 30. So we'll be thinking in those lines. So if you say cosine of 150, we are saying, is cosine positive or negative in the second quadrant? It is negative, so it will be negative. Now what is actually the value of cosine 30? It's negative root of 3 over 2 from the special triangle. Tan 30 is like sine divided by the cosine value, which is like multiplying by the reciprocal. The 2's will go away, so we have like negative 1 over root of 3. So negative 1 root of 3. And then cotangent will be 1 over that, so to the reciprocal. And then secant 1 over cosine to the reciprocal of the cosine value. And then cosecant 1 over sine, so sine was 1 over 2, so it will just be a 2 reciprocal as well. So this is basically how you fill in this table. If you've understood whatever we've done here, then you are good to go. You have a very strong foundation under trigonometry. So with whatever we've done, feel free to pause the video and try out these questions. Okay, so continue and look at question 2. So we've looked at the very basics of trigonometry. We looked at graphs, we looked at the special triangles. So we'll apply the same concepts. I believe we've also looked at the issue of us finding the difference angles. Okay, so in the following, one of sine x, cosine x, tan x is given, and then we need to find the other two if x lies in the specified interval. Okay, so I believe you know identities already, so it don't be a struggle for you to be able to understand these, right? Okay, so one way of actually dealing with this is by looking at the SOHCAHTOA. So we use the right angle triangle. So we use this triangle for all our examples to do our work faster. You can also use identities separately, but I will use a triangle. So SOHCAHTOA, the term SOHCAHTOA actually is like this. SOHCAHTOA. So we call these trig ratios. So this term helps us to remember them. The first one is sine. So sine theta means opposite over hypotenuse. And then cosine of theta is equal to, so that's adjacent over hypotenuse. Now previously, from the previous question, I explained what these are. And then tan theta means opposite over adjacent. Alright, so I'll be using these trig ratios to get the values that we have been given there. Okay, so if you're focusing on this angle, So in this case, let's use this angle as our angle x. We'll use it as angle x. So if you look at this angle x, its opposite is on the side that is opposite is actually the opposite side, and then this other side, which is not the hypotenuse, is the adjacent side, and then the longest side, of course, where the 90 points at, we call that the hypotenuse. Okay, so with that in mind, let's look at the first one. So the first one tells us sine of x is equal to 3 over 5. Now, you know what sine is. Sine is like opposite over hypotenuse, so we have like 3 over 5. So if you have 3 over 5, it means that your opposite becomes what? 3. Your hypotenuse becomes 5. As simple as that is. So if that is the case, Pythagoras theorem also tells us that the sum of the square of the hypotenuse, which in this case is 5 squared, should be equal to the summation of the other two adjacent sides. So it would be 3 squared, and then the unknown side can be said a squared. Okay, so 5 squared is 25 minus 9. So you actually get to notice that your 25 minus 9 is 16. Square root of 16 will give us a 4. So this missing side becomes a 4. Now the moment you just find that, you find that it will be very easy for you to actually get to find all these other things. So how do you find the other angles? How do you find the other two? So it will just be as simple as cosine of the x, cosine of x. Now cosine, we know that it's adjacent over hypotenuse, from what we're able to see here from SOHCAHTOA. Adjacent over hypotenuse. So what's adjacent? Adjacent in this case becomes 4. So for cosine of x, it will be, the adjacent is 4, the hypotenuse remains 5. For tan of x, it is opposite over adjacent. So the opposite is 3, adjacent is 4. So we found the other two for the first one. Very simple, right? So I believe the remaining shouldn't be struggles for you now. Okay. Now if we go to the next one, the next one we've been given tan x to be equal to a 2. Tan of x to be equal to a 2. How do you answer that one? So that one can actually, we assume you have 2 over 1. So in such a case, the opposite becomes 2. And then our hypotenuse becomes what? In fact, for tan, it's opposite over adjacent from SOHCAHTOA. So the opposite is a 2, the adjacent is like 1. So the hypotenuse becomes the summation of these 2 squared. So 2 squared plus 1 squared should give us the hypotenuse. We call it a squared or c squared. And then if you have like a 4, and then you have like plus a 1, so it will be root of 5. Okay. So the moment we do that, we should be able to find all the other two sides. So how do we do it? So you're going to have like tan has already been given. So sine is obviously going to be the opposite. Sine x, the opposite is a 2 over the hypotenuse. For cos, it will be adjacent, which is 1 over root of 5. Okay. So pretty much there's nothing complicated about whatever we're supposed to basically do there. I don't even know the point of giving us the domain, because I believe we're not finding the values of x, so it will still be easy. And then cosine of cosine of what? Cosine of x, and then 1 over 3. Cosine of x, 1 over 3. So cosine, it is adjacent over hypotenuse. So the adjacent is here, the hypotenuse becomes that one. So first, to find the missing side, the hypotenuse is 3 squared, so subtract minus 1 squared should be able to give us the other side. can call it b squared. So 3 squared is 9 minus a 1, that's like 8, so root of 8. And then tan will be the opposite of the adjacent, so it will be root of 8 over 1 for tan of x. And then for sine of x, opposite of hypotenuse, root of 8 over 3. Okay. Now we've gone to the ones with the negatives. So we have like cosine of x is equal to negative 5 over 13. Okay. So you can have something like this. So if we had to come up with the quadrants, so we know that all students take coffee. So they are all positive in the first quadrant, and then in the other quadrants, cosine is positive in the last quadrant, then these other two, it will be negative. Now if you look at the domain we're given, we are told if the value of x is between 90 and 180. This is like pi over 2. Pi over 2 is 90 degrees. Pi is like 180 degrees. So if the value of x is between that. So in this case, looking at the part which can give us cosine to be negative, it's in the second and the third quadrant. So now looking at the value of x to be between pi over 2. Pi over 2 is there. Pi over 2 is there. And then with pi. So meaning that it's supposed to be in the second quadrant. And so if we're in the second quadrant, what that tells us is the triangle will be in the second quadrant. So if it's in the second quadrant, it will be like this. So the basic idea there tells us that the side which is expected to be negative is the x-axis. So which would be like, in this case, it's what? It would be the adjacent if we take this one to be the x. So the adjacent can be 5, negative 5, and then the hypotenuse can be 13. Wait, yeah. Since cosine is adjacent over the hypotenuse. So, by the way, we can ignore the negative in terms of our calculations. It will still be dealt away with. I needed to mention all those complicated stuff just to help you just like have an idea of whatever we're doing here. So, now how do we find the other two? And I think it was actually necessary for me to explain everything else from where we're coming from. Yeah, but anyway, I would have to I didn't pay attention to the values of x, sorry. Yeah, anyway, so the values of x are very important. I don't know how I skipped that. The values of x are very important. So if you look at the pi over 2 and pi for the first question, that tells us we're dealing with a second quadrant. So if you're dealing with a second quadrant, it means that, remember I said all students take coffee. So in such a case, only the sign is positive, so the other two answers were supposed to be negative. Okay, that's very important. I don't know how I overlooked that. For B as well, we are looking at 0 and 90, so that's the first quadrant. So here all are supposed to be positive, that's fine. All are supposed to be positive because we're in the first quadrant. For C, that we have from previously undering, is between negative pi over 2 and 0. So that would mean that we're actually looking at so this would be like negative pi over 2, and then that would be like your 0. So that means we're dealing with the fourth quadrant for C. meaning that cosine is the only one that's going to be positive, and then the other two answers are expected to be negatives there. I think I needed to mention that as well. Very important. Very, very important. Yeah. Sorry for the previous questions. I hope you can just correct the solutions. Just add the signs, take note of the values of x. Okay. So if we look at this one then, the fact that we are in the, which quadrant is this? Between pi over 2 and pi, that's like second quadrant. So only sine will be positive here. Okay. So therefore sine, we can find the missing side by using Pythagoras theorem. 13 squared minus 5 squared, which would be like 169 minus like 25. That would be like 144. So like that's like a 12, I believe. 12. Wait. That should be 12. So if that's the case, my math is correct. We can say our sine x will be, the opposite is 12, the hypotenuse is 13. So it's a positive value. And then for tan, it will be negative since we're in the second quadrant. So it will be like negative what? So opposite 12, adjacent 5. So it will be negative 12 over 5. Yeah, pretty much. I think this is like the basics that you need to answer the remaining questions. But I'll still feel free to pause the video and try out whatever is remaining. I think they're essential. Okay, so if you look at E, tan of x, so I can draw back the triangle there. Tan of x. So if we take this to be our x, so Katoa tells us we have tan theta is equal to opposite over hypotenuse, opposite over adjacent from Sokatoa, sorry, Toa, opposite over adjacent. So if we have 1 over 2, the opposite is a 1 then, and then the hypotenuse is like a 2. Sorry, the adjacent, it's opposite over adjacent, so adjacent is going to be a 2. The hypotenuse can be found by squaring the two sides and then add them and then find the square root. So 1 squared plus 2 squared, that's like 1 plus 4 is root of 5. Okay, so which quadrant are we in if you look at the value of x here? So observing the value of x 3 pi over 2, so I like between 180 and this part. So we are like in the third quadrant. So in the third quadrant, all students take, so tan is the only positive one there, so all the other answers will be negatives. So sine of x will be negative, the opposite is like 1, hypotenuse is root of 5, and then for cosine of like x is going to be like 1 over root of 5. No, the adjacent is 2, so negative 2 over root of 5. Okay, yeah, I hope you understand. So I think you've gotten the idea here. You've gotten the idea. You should be able to pause and just like answer the last one to just build some confidence. So sine of x is negative 1 over 2. So this is like also the same quadrant, the third quadrant. So sine, as we can actually see, is negative. So we only expect again only tan to be like the positive one. Okay. So sine, in this case, it is the opposite being a 1 and then the hypotenuse like being a 2. So we need to find the missing side. So it will be like 2 squared minus 1 squared. That's Pythagoras theorem. So that's like 4 minus like 1. So root of 3 here becomes the adjacent side. So with confidence, we can easily get just to find the missing ones. So cosine x, the adjacent is root of 3 over the hypotenuse 2. Now this is going to be a negative since we're in the third quadrant, and then tan will obviously be a positive. So we have like the opposite being a 1 and then the adjacent being like a 2. Yeah, how is it 2? It's root of 3. It's root of 3, root of 3, it's root of 3. Okay, so tan of x, the opposite is like a 1, the adjacent is like root of 3. We are good to go. So that's how we answer question 2, as easy as it looks. So with the trig ratios that we actually have, let's have a triangle. Quick one. Okay, so we'll take this one to be x again, and then so for the first one, let's of course take note that the quadrants are very important. I think that's why the values of x were given, because of the quadrants, so that we know which quadrants we are talking about. I hope you're now familiar with the radians. So that's like 0, that's the 90 is like pi over 2, that is pi, this is like 3 pi over 2, and then that becomes 2 pi. You would have to be smart about it. If we go this way, if we move clockwise, this would be negative pi instead. Okay, negative pi over 2, that is. Yeah, but I hope you know the quadrant. So all students take coffee. That's a phrase that helps me to remember where one of these is positive or negative. So in the first quadrant they're all positive, and then in the second quadrant sine is positive, tan positive there, as we can clearly see. Okay, so for the first one we have pi over 2 and pi, which tells us we are in this quadrant where only sine is positive, so the other two will be like negatives. So if you have sine theta, sine x being equal to 3 over 5, what that tells us is you have like the opposite being 3, the hypotenuse being 5. So you can use the Pythagoras theorem to find the missing side. So 5 squared minus 3 squared, 25 minus 9 is 16, root of 16 is a 4. Interested in the positive answer alone. So you can easily find the missing ones. So cosine being the first one, cosine, the trig ratios here tell us it's adjacent over hypotenuse, so the adjacent is obviously a 4, and then the hypotenuse is 5. Now we'd be negative or positive. We are in the second quadrant, it will be negative because only sine is positive in that quadrant. And then for the other one, which is tan of x, will also be negative. Now it will be opposite over the adjacent. The opposite is 3, adjacent is a 4. So we've answered both. So the values of x here are like helping us determine the what is ahead of us, of course. And then if you go to b, there we have like tan x is equal to 2. So you can basically take that to be very important. So you can have it like 2 over 1, so that like the adjacent becomes a 1 and then the opposite becomes a 2. You can find the hypotenuse, 2 squared plus 1 squared, so 4 plus 1, so root of 5 there. And then obviously which quadrant is that? Between 0 and pi over 2, that's like 0 and 90, first quadrant, so they are all positive there, so all the answers will be positive. So you can easily apply the concept So sine of x will be the opposite, which is a 2 over the hypotenuse. Cosine will be the adjacent over the hypotenuse. Okay. And then we can go to the third one, C. For C, we have 1 over 3. Now, cosine means opposite. Is it opposite? No. Adjacent over hypotenuse. So the adjacent is a 1, the hypotenuse 3. We can find the opposite side. So we have 3 squared minus 1 squared. That is like 9 minus 1. Gives us 8. So the root of 8. So therefore, this is between negative pi over 2 and 0. So this is why I needed to mention you needed to be very careful there. Okay. So if you are going the anti-clockwise way, that's when you begin to have a negative angle. So negative pi over 2 will be somewhere here. That means you are moving anti-clockwise. So in other terms, that is only important because it's helping you determine the quadrant you are in. So the quadrant you are in is like the 4th quadrant. So in this quadrant, only cosine is positive. The rest are negatives. So as we're given cosine, actually is positive. So the others will be negative. Now what do we have? 1 over 3. Why have I removed? Yeah, 1 over 3. So the same ones actually. So sine will be the opposite, to be negative, the opposite over the hypotenuse. And then tan will also be negative. Okay. Over 1, which will not change anything. So basically, that's how you handle questions here. Okay, so continue and look at question 2. So we've looked at the very basics of trigonometry. We looked at graphs, we looked at the special triangles. So we'll apply the same concepts. I believe we've also looked at the issue of us finding the difference angles. Okay, so in the following, one of sine x, cosine x, tan x is given, and then we need to find the other two if x lies in the specified interval. Okay, so I believe you know identities already, so it don't be a struggle for you to be able to understand these, right? Okay, so one way of actually dealing with this is by looking at the SOHCAHTOA. So we use the right angle triangle. So we use this triangle for all our examples to do our work faster. You can also use identities separately, but I will use a triangle. So SOHCAHTOA, the term SOHCAHTOA actually is like this. SOHCAHTOA. So we call these trig ratios. So this term helps us to remember them. The first one is sine. So sine theta means opposite over hypotenuse. And then cosine of theta is equal to, so that's adjacent over hypotenuse. Now previously, from the previous question, I explained what these are. And then tan theta means opposite over adjacent. All right, so I'll be using these trig ratios to get the values that we have been given there. Okay, so with the trig ratios that we actually have, let's have a triangle. Quick one. Okay, so we'll take this one to be x again, and then so for the first one, let's of course take note that the quadrants are very important. I think that's why the values of x were given, because of the quadrants, so that we know which quadrants we are talking about. I hope you're now familiar with the radians. So that's like 0. That's the 90 is like pi over 2. That is pi. This is like 3 pi over 2. And then that becomes 2 pi. You would have to be smart about it. If we go this way, if we move clockwise, this would be negative pi instead. Okay, negative pi over 2, that is. Yeah, yeah, but I hope you know the quadrant. So all students take coffee. That's a phrase that helps me to remember where one of these is positive or negative. So in the first quadrant they're all positive, and then in the second quadrant sine is positive, tan positive there, as we can clearly see. Okay, so for the first one we have pi over 2 and pi, which tells us we are in this quadrant where only sine is positive, so the other two will be like negatives. So if you have sine theta, sine x being equal to 3 over 5, what that tells us is you have like the opposite being 3, the hypotenuse being 5. So you can use the Pythagoras theorem to find the missing side. So 5 squared minus 3 squared, 25 minus 9 is 16, root of 16 is a 4. Interested in the positive answer alone. So you can easily find the missing ones. So cosine being the first one. Cosine, the trig ratios here tell us it's adjacent over hypotenuse. So the adjacent is obviously a 4, and then the hypotenuse is 5. Now we'd be negative or positive. We are in the second quadrant, it will be negative because only sine is positive in that quadrant. And then for the other one, which is tan of x will also be negative. Now it will be opposite over the adjacent. The opposite is 3, adjacent is a 4. So we've answered both. So the values of x here are like helping us determine the what is ahead of us, of course. And then if you go to b, there we have like tan x is equal to 2. So you can basically take that to be very important. So you can have it like 2 over 1, so that like the adjacent becomes a 1 and then the opposite becomes a 2. You can find the hypotenuse, 2 squared plus 1 squared, so 4 plus 1, so root of 5 there. And then obviously which quadrant is that? Between 0 and pi over 2, that's like 0 and 90, first quadrant, so they are all positive there, so all the answers will be positive. So you can easily apply the concept. So sine of x will be the opposite, which is a 2 over the hypotenuse. Cosine will be the adjacent over the hypotenuse. Okay, and then we can go to the third one, c. For c we have 1 over 3. Now cosine means opposite. Is it opposite? No, adjacent over hypotenuse. So the adjacent is a 1, the hypotenuse 3. We can find the opposite side. So we have 3 squared minus 1 squared. That is like 9 minus 1. Gives us 8. So the root of 8. So therefore, this is between negative pi over 2 and 0. So this is why I needed to mention you needed to be very careful there. Okay. So if you are going anti-clockwise, well, that's when you begin to have a negative angle. So negative pi over 2 will be somewhere here. That means you are moving anti-clockwise. So in other terms, that is only important because it's helping you determine the quadrant you are in. So the quadrant you are in is like the fourth quadrant. So in this quadrant, only cosine is positive. The rest are negatives. So as we're given cosine, actually is positive. So the others will be negative. Now what do we have? 1 over 3. Why have I removed? Yeah, 1 over 3. So the same ones actually. So sine will be the opposite, to be negative, the opposite over the hypotenuse. And then tan will also be negative. okay, over 1, which will not change anything. So basically that's how you handle questions here. I've gone to the ones with the negatives. So we have like cosine of x is equal to negative 5 over 13. Okay, so you can have something like this. So if we had to come up with the quadrants, so we know that all students take coffee, so they are all positive in the first quadrant, and then in the other quadrants, cosine is positive in the last quadrant, then these other two it will be negative. Now if you look at the domain we're given, we are told if the value of x is between 90 and 180, this is like pi over 2. Pi over 2 is 90 degrees, pi is like 180 degrees. So if the value of x is between that, so in this case, looking at the part which can give us cosine to be negative, it's in the second and the third quadrant. So now looking at the value of x to be between pi over 2, pi over 2 is there, pi over 2 is there, and then with pi, so meaning that it's supposed to be in the second quadrant. And so if we're in the second quadrant, what that tells us is the triangle will be in the second quadrant. So if it's in the second quadrant, it will be like this. So the basic idea there tells us that the side which is expected to be negative is the x axis, so which would be like in this case it's what, it would be the adjacent if we take this one to be the x. So the adjacent can be 5, negative 5, and then the hypotenuse can be 13. Wait, yeah, since cosine is adjacent over the hypotenuse. So by the way, we can ignore the negative in terms of our calculations, it will still be dealt away with. I needed to mention all those complicated stuff just to help you just like have an idea of whatever we're doing here. So now how do we find the other two? Okay, so if we look at this one, then the fact that we are in the, which quadrant is this, between pi over 2 and pi, that's like second quadrant, so only sine will be positive here. Okay, so therefore sine, we can find the missing side by using Pythagoras theorem. 13 squared minus 5 squared, which would be like 169 minus like 25, that would be like 144. So like that's like a 12, I believe. 12, wait, that should be 12. So if that's the case, my math is correct, we can say our sine x will be, the opposite is 12, the hypotenuse is 13, so it's a positive value. And then for tan, it will be negative since we're in the second quadrant, so it will be like negative what? So opposite 12, adjacent 5, so it will be negative 12 over 5. Yeah, pretty much. I think this is like the basics that you need to answer the remaining questions, but I'll still feel free to pause the video and try out whatever is remaining. I think they're essential. Okay, so if you look at E, tan of x, so I can draw back the triangle there. So if we take this to be our x, so Katoa tells us we have tan theta is equal to opposite over hypotenuse, opposite over adjacent from Sokatoa, sorry, Toa, opposite over adjacent. So if we have 1 over 2, the opposite is a 1 then, and then the hypotenuse is like a 2. Sorry, the adjacent, it's opposite over adjacent, so adjacent is going to be a 2. The hypotenuse can be found by squaring the two sides and then add them and then find the square root. So 1 squared plus 2 squared, that's like 1 plus 4 is root of 5. Okay, so which quadrant are we in if you look at the value of x here? So observing the value of x 3 pi over 2, so I like between 180 and this part, so we are like in the third quadrant. So in the third quadrant all students take, so tan is the only positive one there, so all the other answers will be negatives. So sine of x will be negative, the opposite is like 1, hypotenuse is root of 5, and then for cosine of like x is going to be like 1 over root of 5. No, the adjacent is 2, so negative 2 over root of 5. Okay, yeah, I hope you understand. So I think you've gotten the idea here. You've gotten the idea. You should be able to pause and just like answer the last one to just build some confidence. So sine of x is negative 1 over 2. So this is like also the same quadrant, the third quadrant. So sine, as we can actually see, is negative. So we only expect again only tan to be like the positive one. Okay. So sine, in this case, it is the opposite being a 1 and then the hypotenuse like being a 2. So we need to find the missing side. So it will be like 2 squared minus 1 squared. That's Pythagoras theorem. So that's like 4 minus like a 1. So root of 3 becomes the adjacent side. So with confidence, we can easily get just to find the missing ones. So cosine x, the adjacent is root of 3 over the hypotenuse 2. Now this is going to be a negative since we're in the third quadrant, and then tan will obviously be a positive. So we have like the opposite being a 1 and then the adjacent being like a 2. Yeah, how is it 2? It's root of 3. It's root of 3, root of 3, it's root of 3. Okay, so tan of x, the opposite is like a 1, the adjacent is like root of 3. We are good to go. So that's how we answer question 2, as easy as it looks. Okay, so if you're actually enjoying this video, you can actually have access to the full trigonometric solutions that will allow you to understand the topic fully. So the question 1 is there, the question 2 is there, the question 3 there, the question 4, identities are also there. As you can see, question 6 and 7 are based on identities. Double angles are also there. Okay, so you'll be able to understand the half angle principles as well looking at question 4. And then as we go to question 8, you'll also be able to understand how to go about it, how to solve trigonometric equations. Question 9 is also there, how to answer more equations. Question 10 dealing with sketching, question 11 dealing with sketching, question 12 dealing with sketching, question 13 sketching as well. And then you also understand how to determine or evaluate these trigonometric kind of expressions, looking at question 14, 15 and also 16 as well. So you can have access to all these solutions by just registering. So you can visit our site, the link is in the description. From there you can also learn the topic from scratch, each basic concept step by step, and also access the solutions to this entire tutorial sheet. Alright, so we can have a look at question 4. So question 4 is a very interesting question which requires us like to find the square. Okay, now I know I've already introduced you to the issue of converting to degrees if you don't understand the angle that you've been given in radians. So if you look at the first one there, if you put a 180 where there's a pi and then put 8, so you get like 22.5. So actually 22.5, previously we've looked at the issue where you like make combinations of the special angles, the 30 degrees, 45 and the 60. So there's no combination you can actually make to get 22.5, and this tells you that you can't actually express that angle in terms of a summation, so it will actually be impossible for you to find the answer in such a way. Okay, so obviously for pi over 12, if you put a 180 and then divide by 12, you get a 15 degrees. So this one will be easy for you to find, and remember we've actually found it previously. Okay, so one thing that you need to know is if you are given like cosine squared like we're given for the first part, or pi over 8, that is, it's the same as whatever you found there, you get to square it. Okay, so now with an understanding that this second one, B, and the third one, these ones actually have been previously answered without the square. I'm sure if you go back to like the third question, you should be able to remember that we actually dealt with sine 15, okay, as actually the first question, and then we also dealt with cosine 15 degrees indirectly, though it was given in radians, so I had to deal with it as well. So remember that for sine of 15, we actually found the value of root of 6 should be minus root of 2 over 4. Okay, and then for cosine, root of 6 plus root of 2 over like 4. Now since we're trying to find like the square of these, so if you want it to be squared, it means that you have to square like the results as well. Okay, now if you have remembered like what we did previously from the previous question, it was actually a lot of work for us to get to this point. It was actually a lot of work. Yeah, but the point that I'm trying to make is, even if you go by this long method, if that's what you're able to remember and you have enough time in your exam or assessments, go by it. You actually have no choice. But this is long, but it's actually a long method, but it's actually correct in terms of the solution. And actually if you try to apply it, you basically get the same result. Maybe just out of curiosity, I can actually show you one. Let's try to deal with this other part. So if you try to square that, root of 6 by root of 6 will be like 6, and then root of 6 by that will be like root of 12, which will come like twice, and then plus 2 after root of 2 by root of 2, and then 4 times 4 will be like 16, and then at this point you're going to have like 8, and then 2. Root of 12 is the same as root of 4, and then root of 3, and then you have like 16. At that point that can reduce to like 8. Root of 4 is 2 times 2 gives us a 4, and then 16. At this point you can divide by like 4 or factor out a 4. That gives us a 2. That is the 1. That is like a 4. So we have like 2 plus root of 3 over 4 as one of the results. So as we might expect, the other side for sine, it will be 2 minus root of 3 over 4. Now you can refer to the previous question on how to get this actually. Okay, so don't forget this answer. Let me actually write it down somewhere here. So it's 2 minus root of 3 over 4. The other one is like a positive. Okay, Now, instead of doing all this, you can actually handle this question much faster. I was just trying to show you the meaning actually behind what it means when you say cos squared of pi over 8 and so on. But there's actually the formula we call the half angle formula. So the half angle formula is an argument to say if you have sine squared of half an angle, a over 2 for example, that's actually equal to 1 minus cosine of the angle itself divided by 2. It can also be in terms of cosine. Cosine a half an angle of a is also minus, this one now becomes plus cosine of the same angle over 2. Of course, if you try to find the exact value removing the square, you end up with a root on this other side, which is probably the one that you've seen. Okay, so this is not actually very hard to remember, it's actually very easy. So the sine square of half an angle, what this means is if you have, it's like sine 15 degrees is actually equal to 1 minus cosine of 30 over 2, meaning that if 15 is not a special angle, I can actually use this identity to actually get to find that. But of course I need to understand that this is actually the sine square of that. So if I'm trying to find the exact value of 15, I would have to like find the square root on the other side. Okay, so cosine, the sign is maintained. For sine, the sign changes. I hope you've gotten that. So you can actually apply that to answer the question we have. So I showed you that pi over 8 is actually not a special angle. It was giving us like 22.5. Okay, so instead of using it 22.5, if 22.5 is doubled, actually you understand that it gives you what, 45. Okay, so instead of doing all that, you can actually just handle it directly. Cos squared of pi over 8 is actually going to be equal to, I said for cosine the sign is maintained, so it will be 1 plus, now pi over 8 is just half an angle, so we multiply it by 2, the actual angle is pi over 4 divided by 2. So here we're not going to find the square root because we're finding the squares themselves. So now cos pi over 4, if you don't understand these regions, pi over 4 is the same as 180 divided by 4, which is like 45. Cosine 45, we've looked at that special triangle already. What's the value? It's 1 over root of 2. Over what? Over 2. Okay. At this point, you can actually multiply both the numerator and the denominator by root of 2. So if you multiply the top part by root of 2, and then on the bottom as well by root of 2. So what you're going to get is 1 times root of 2 will be root of 2. Where we have 1 over root of 2, it will just be like 1, and then on the bottom it will just be like 2 root of 2. Okay. And then at that point you're at liberty now of simplifying that. Okay, you can multiply by the what? By the denominator, so that you like do away with whatever we have. So you can multiply again by root of 2, again by root of 2. So if you multiply by root of 2 by root of 2 will be a 2, and then 1 will be root of 2. Denominator, you have 2 times root of 2 by root of 2 will be 2, so 2 times 2 will be like a 4. Okay, can you go a bit further than that? Okay, so we have 2 plus root of 2, and then we have like over a 4. Can we simplify it beyond that? Okay, we'll end it there. And then we can try the other one. I believe pi over 4. Oh yeah, actually that's the answer. We end there. I don't know what was on my mind. So if we go to The other one is pi over 12. So instead of, even if we know that this one is going to give us a special angle, if we try to perform all 15 degrees, which are able to express in the form of special angles, the 45 minus the 30, and then you apply the identity. Yeah, you can also handle it that way if you want to, if you've forgotten this method that I'm teaching you about the half angles, so that you can just say sine 45 cos 30 minus cos 45 sine 30. Yeah, you can find that and then you get to square it. I've already shown you how to go about that, but let me show you the half angle. So the half angle formula says the square of that half angle will be 1 plus cosine. This is the half angle, so the original angle is obviously going to be times 2. So if you multiply pi over 12 by 2, you're going to have pi over 6. Okay, that's simple mathematics. Times 2, 1, 6. Over what? Over 12. Over 2. How is it over 12? Over 2. That's the formula. It's 1 plus twice the angle over 2. Don't forget this side is squared. And then pi over 6. If you can't think in radians again, just put the 180 there. 180 divided by 6 is like 30. 180, pi is the 180, so 180 over 6 is like 30. So cosine of 30 is what? Root of 3 over 2, if you are able to remember your special angles. And then over 2. Yeah, so you can actually multiply by 2, both the numerator and the denominator. So that you do have a fraction there. So going to have 2 plus root of 3 over 4. Here it will cancel, there it will become 2, on the bottom it will become a 4. So you can remember this answer that we actually found, right? So that is for the cosine one. And then you can actually try out the C. So for C it is sine squared. So I said for sine squared the sign changes, so it will be 1 minus, but we don't have sine, it just to be cosine again. Cosine double the angle, which is pi over 6 again, over 2. So 1 minus, it will still be root of 3 over 2 over 2. So the answer will still be 2, the sign will change, over 2. Okay. So in other terms, since we're dividing by 2, it's more like we're just multiplying the entire thing by half. Well, is that true? Yeah, is it? Yeah, that's true, that's true, that's true. Yeah. So that would be like half for common denominator and all. And then pause the video to answer the last one. So for the last one, as you might guess, will be sine squared pi over 8. So for sine, I said the sign changes, so it will be cosine, double the angle, give us pi over 4 over 2, and then 1. Cosine pi over 4 is what? So pi over 4 is 180 divided by 4, 45. Cosine 45 is 1 over root of 2, over 2. Multiply by root of 2. Root of 2 minus 1 over 2 root of 2. You can end there if you want to, but if you want you can do a good job by multiplying by root of 2 again, which will be 2 minus root of 2 over 4. Okay, that's the answer. So basically, in summary, know that the sine square of that of any half angle is actually, so sine squared of any angle is actually equal to 1 minus cosine, if that is an half of an angle, the angle itself over a 2. And then for cosine, it's the same thing, the sign, except here you have a positive sign in between. I think that's the major difference that you just need to appreciate. So in other textbooks, if you've put an a there, on the other side it will be 2a. It's the same concept, please don't get confused. Okay, it's like if you have an half here there, you'll be like twice whatever you have there. So pretty much this is how you're supposed to handle question 4. Question 5. So prove the following trigonometric identities. So I'm sure this is not new to you. We already talked about these identities, where if you say you have cosine of a plus b, so I told you to say cosine is actually selfish, so that implies it will take both cos a and then also cosine of b, and then you subtract the other one now, sine a and then sine b. Now for sine, it is not, it shares, and then it maintains the sign. So you have sine of a, and then you also have cosine of the other one, and then you maintain the sign again, you exchange. Now sine will now apply to b, and then cosine will now apply to a. That's the difference between the two. Okay, so let's apply the same concept. So for the first one, cosine of x minus pi over 2. So you can pause the video and just try it out. So we said cosine is selfish, so it will be cosine of x and then cosine of pi over 2. Ignore the sign. Now the sign does change, so since it is a negative here, it will become a positive this side, and then now sine can come in, sine of x and then sine pi over 2. So I believe if you are not conversant with radians, I told you can convert to degrees. So pi over 2, put 180 where there's a pi, it will be 180 divided by 2, which is a 90. So by this time, you should also be conversant actually to the graphs of these. So for cosine, the graph starts there like this. So meaning that you have 0, we have a pi over 2, which is a 90, of course, and then you've got 3 pi over 2, which is like a 270, and then you have like, wait, what have I done? No, it's actually pi at this point. Pi over 2, after half, you have pi and then 3 pi over 2, and then finally you have at that point 2 pi. Yes, so that is the same as 90, 180, 270, and then 360. Okay, so if you have cosine pi over 2, where is that? Cosine pi over 2, it's at this point. So the graph is actually at 0, because remember that is a 1, this is like a negative 1, and this is a 0, so this part becomes equal to 0. If it was in case of sine, where we've got sine pi over 2, you know that sine starts from 0, so this is the way it actually gets to move like this. So this is like the 90 with pi over 2, so it's 1 actually for sine. Okay, you can actually use the special triangles if you want. So we're going to have now cosine of x multiplied by 0 and then plus sine of x. Now sine pi over 2 or sine 90 is equal to 1, so this part will go, you only remain with sine of x, which means we've now proven to say that's actually correct. So at this point, I'm sure you've understood what I was trying to explain, so you can actually try to attempt the others. Let me give you the other one. Cosine of x plus pi over 2. So again, cosine is selfish, so it will first of all get, and then the other one can come in later. So cosine of x and then cosine of pi over 2. The sign changes, it becomes negative, so we'll now have sine of x, sine pi over 2. So again, these are just like identical, it's just like the same ones we add. So cosine of pi over 2, we say that's a 0, so this part will be eliminated, and then minus sine of x, sine pi over 2 is also a 1, so this just gives us like a negative sine of x. Okay, Very simple, right? Okay, you can try out the remaining ones. So for C, we have sine x plus pi over 2. So sine shares. So we have sine x, cosine of the other part. The sine maintains, and then sine can now apply to pi over 2, and then cosine can now apply to x. Okay. So sine x, cosine pi over 2 still remains a 0, right? Cosine 90 is a 0, so we have a 0 again, plus sine pi over 2 is a 1, cosine of x remains. So 1 times cosine of x is just cosine of x. Okay, we're good. And then finally, the sign changes. What happens after changing the sign? So the sign will also apply. So we have sine of x, cosine pi over 2, the sign in between will change, and then negative sine will now apply to pi over 2, and then cosine will apply now to x. So all the same again. At this point, this is equal to a 0, so you have sine of x, pi by 0 minus sine pi over 2 is a 1 times cosine of x. So this will go, you remain with negative cosine of x. So I believe I've already summarized like the basic idea about the sine and the cosine. Whenever you have addition or subtraction in the brackets, these are very simple and basic identities that you need to know, because we'll use them. We'll use them later. Question 6 is like based on the same concept. So we can start with the first one. We just need to express them in the form of sine of x and cosine of x, which implies we need to do away with the angles and just remain with the variable x. So for the first one, we have cosine of pi plus x. So I already explained how to expand this. So cosine of pi plus x is the same as cosine is selfish, so cosine pi, cosine of x, and then you now have like the sign changes, sine pi, cosine x. Okay, and then what do we have? This is simplified to cosine pi or cosine 180. I've forgotten. I'll draw the graph. I know the graph starts from 1 like that, and I know that is a 1, this is like a negative 1. So this is a negative 1, a 1 and a 0. So it starts at 0, and then you have pi over 2, which is 90, and then you have pi, which is 180, and then you have 3 pi over 2, which is like 270, and then you have 2 pi. So at this point, cosine pi, this is the pi, so this is like negative 1, so you have like negative 1 multiplied by cosine of x minus sine pi. Now the sine graph behaves in a different way. It starts from here, so it's like, anyway, I can just like, yeah, it starts from here. So okay, obviously we know sine pi. Anyway, I've forgotten, let me just draw again. So it starts from 0 like this. Okay, so you have 0, pi over 2 here, pi is at 0. Okay, so this is a sine graph. That is of course a 1, this is like a negative 1 again, so that's like a 0, and then you have cosine of x. So the only part that is remaining here is negative cosine of x. So you've expressed it in the form of cosine of x without remaining with any other angle. Then you can go to the other one, which is a b. We have sine 2 pi minus x. So sine shares, it maintains the sign, so sine 2 pi cosine of x, the sign is maintained in between, and then we'll have now sine will now apply to x, and then cosine will now apply to 2 pi. So this is like the ending power point of the graph. Okay, so take note of the sine graph starts like this. Okay, wherever it starts from, that's where it ends from actually. So if it starts from 0 like the sine, it will end at 0 again. For the cosine, it starts at 1 and then ends at 1 again for 2 pi. Remember, the end point is 2 pi. So sine 2 pi therefore becomes 0, because that's where it starts from. And then negative sine x, cosine 2 pi, where is that? Where it ends starts at the 1, so it will end at the 1 again. That's 2 pi, so it ends at the 1, as you can see from the graph. So what do we have? This goes, and then you just have like negative sine of x. We can now go to the other part. Sine 3 pi over 2 minus of x is like equal to, again sine shares, right? 3 pi over 2 cosine of x, and then the sine maintains, and then we can now have sine now applying to x, and then cosine applying to the other part. Okay, so this is like 270. So the graph again will still help me since I don't have a good memory. So this is a graph for cosine, though it's not not very accurate. Okay, I know the graph is supposed to be divided in like 4 parts. So 0, pi over 2, 180, which is pi, and then 3 pi over 2, and then 2 pi. Pi over 2, pi, 3 pi over 2, and 2 pi. So for this one, what we have is 3 pi over 2. So for sine, 3 pi over 2 is at the negative 1 there. So we have a negative 1 there, and then cosine of x. Now for the cosine graph, which starts from there to come like this, so it's 0. So it's at 0 there. So say minus sine of x, and then a 0. Hopefully I'm right there. This is where the graph comes out. Yeah, it's at 0. So we are just going to remain with negative cosine of x. The other part will be eliminated. And then we now have the last one. Feel free to pause the video and just try it out. Cosine 3 pi over 2 plus x. So cosine selfish, cosine 3 pi over 2 cosine of x. What am I writing there? Cosine 3 pi over 2 cosine x, the sign changes, and then sine can now also get the share of both. Okay, so this is just like a repetition of what I'm talking about. So if you've got a good memory, I think I can try at this point. Cosine 3 pi over 2 is like, it's a 0. If you go to a cosine graph, which starts from a 1. So pi over 2 pi, 3 pi over 2, and then 2 pi. So it's a 0 minus sine of that. Is it a negative 1 or a 1? I think it's a negative 1. So if you look at the sine graph, it's like this. So 0, pi over 2 pi, Okay, so it's a negative 1. 3 pi over 2. Negative 1. So we have a negative 1 and then sine of x. So yes, we are going to have a positive result. This is a 0. Negative times negative is a positive, so I have sine of x. So we've expressed all these four in the form of sine x and cosine x. No angles in radians are appearing in our final solutions. Okay. So if you're actually enjoying this video, you can actually have access to the full trigonometric solutions that will allow you to understand the topic fully. So the question 1 is there, the question 2 is there, the question 3 there, the question 4. Identities are also there. As you can see, question 6 and 7 are based on identities. Double angles are also there. Okay. So you'll be able to understand the half angle principles as well, looking at question 4. And then as we go to question 8, you'll also be able to understand how to go about it, how to solve trigonometric equations. Question 9 is also there, how to answer more equations. Question 10, dealing with sketching. Question 11, dealing with sketching. Question 12, dealing with sketching. Question 13, sketching as well. And then you also understand how to determine or evaluate these trigonometric kind of expressions, looking at question 14, 15, and also 16 as well. So you can have access to all these solutions by just registering. So you can visit our site, the link is in the description. From there you can also learn the topic from scratch, each basic concept step by step, and also access the solutions to this entire tutorial sheet. Okay, let's talk about the identities now. We've got question 7 about the identities. So if you are one of the people who've already accessed the course, or possibly even the video on YouTube about like the full topic trigonometry, I already introduced you to all the identities and how you can easily remember them. Okay, so we'll go straight into answering of the questions. So if you've not watched that, make sure you do watch that. But just a quick recap, just know that if you have sine squared of x plus cosine squared of x, this is equal to a 1. Now just from here we can come up with other identities, knowing that the basic identities that I introduced earlier, 1 over cosine of x is secant of x, 1 over sine of x is cosecant of x, and then 1 over tan of x is cotangent of x, knowing that these are the three basic simple identities that we have. And then not forgetting of course that tan of x is equal to sine of x over cosine of x, and not forgetting that this is also equal to cosine of x over sine of x. Okay, so if we are to divide by sine in this entire equation, what are we going to get? So for the first one, we have sine dividing into itself, we get a 1. And then for the second part, cosine over sine is the reciprocal of tan, which is cotangent of x, so it will be squared. And then equal to 1 over sine is cosecant, so it will be squared as well because of a square. So I've already shown you one of these identities already, just from here. Okay, but after dividing by sine squared of x. What if we now divide by cosine squared? Can also come up with another identity. So for the first one, we're going to have tan squared of x, and then we get a 1, and then the other side we get sec squared of x, because 1 over cosine is secant of x. Okay, you can actually even see that identity just on top there. Yeah, pretty much. The other things that we've talked about are the issues to deal with, like double angles and all. So remember the case where I can give an example of this, since I can see it somewhere there. We talked about sine a plus b, where we said sine actually does share, so it will be sine of a and then cosine of b, and then again the sine will be maintained, and then sine will now apply to b, and then cosine will now apply to a. So in a case of a double angle, it means instead of having a and b, you're going to have just a. So we can take it as 2 theta means theta plus theta. So that would mean that you're going to have sine theta, cosine of theta, again you're going to have the same, sine theta again, and then cosine theta. So that gives us 2 sine theta, cosine theta. Of course, even for cos as well, as you might guess, since cosine comes twice, it will be cosine squared of theta, and then the sine, since it changes, it will be minus sine squared of theta. Okay, so these are the few things that I feel are necessary for you to know before we just get into the answering of these many questions we have. So beginning with the first one, whenever you're proving identities, I recommend getting the part that is more complicated, or that looks, or that needs simplification for you to do it or handle it in a better way. Okay, so for the first one, we have tan squared of x plus 1 being equal to secant squared of x. So I feel the left hand side is more complicated. So our left hand side is identically equal to tan squared of x plus a 1. So tan squared, I already explained. I think I said tan squared of x is like equal to what? Tan squared of x is like equal to sine squared. So tan is equal to sine over cosine. So if it is to be squared, even these other things will be squared. So sine squared, cosine squared, plus a 1. So what do we want to see? What we want to see is secant squared of x, which I believe secant squared of x with a leakage is like 1 over cosine squared of x. Okay, so if we get to come up with a common denominator just there, cosine squared of x will be the common denominator, and then you're going to have divide cosine into itself, it will be a 1 times sine squared of x, and then where we've got a 1 divide a 1, it will give us cosine squared of x. Now remember, where we are going is, our goal is we only want to remain with, since we have sec squared of x, it's 1 over cosine squared of x, so we just want to remain with a 1 on top. Now already this is clearly showing that, say, sine squared plus cosine squared of, it's already giving us a 1 by itself if you add the two. Remember, that is the first identity I gave you, so which is now identical equal to sec squared of x. So you can even put the conclusion hence proven. Before you can actually make that conclusion, you have to explicitly state to say, therefore the left hand side is equal to the right hand side, hence proven. Yeah, simple as that is. So the same idea can be applied to the other remaining questions. Let's go to B. So for B, we have sec of x minus cosine of x equal to sine of x tan of x. So I don't know which one looks easier for you. I don't know which one looks easier for you, but I would prefer going for the product one. So I'll get the right hand side. The right hand side is equal to sine of x and then tan x. So we can try to simplify. So sine of x, and then tan is the same as sine of x over cosine of x, right? So already you're able to see that this is going to be rough. Okay, I can just try again. Left hand side, secant of x minus cosine of x. Secant is the same as 1 over cosine of x. Okay, at least we can come up with a common denominator. Cosine of x, cosine x is a 1, gives us a 1, 1 there is the cosine of x times cosine of x will be cosine squared of x. Now 1 minus cosine squared of x is what? Okay, some of you may not know, so I'll do this. So where there's 1, I believe it's the same as sine squared, or let me just show you the same identity that I started with, where we said sine squared of x plus cosine squared of x is equal to a 1. If you make sine the subject, this one will go the other side, it become a negative, so it will be 1 minus that. Equally, if you make cosine the subject, to be 1 minus cosine squared of 1 minus cosine squared of x. So it's like, in this case, since you have got 1 minus cosine squared of x, that is equal to like sine squared of x over cosine of x. Now since that on top there we've got like double, you can break that one into 2, sine x, and then one part can be divided by the cosine of x. So if you divide that, now you're going to have sine of x, sine divided by cosine is now tan of x. So you can now make the conclusion the left hand side is equal to the right hand side, and it's proven and all. Okay, so I was trying to show you to say you can actually, because I like solving freestyle, I don't solve in advance so that you can see how to approach questions as I've shown you from B. Now for C, we have sine theta plus cosine of theta squared, then 1 plus sine 2 theta. I feel this one is more visible, able to say which one is more complicated. I think the left hand side is clearly complicated, so I can go direct into expanding it. Since it is squared, it means sine theta plus cosine theta, again the other bracket like that. We can now multiply. So sine from this one bracket to by the other one there, sine squared theta, and then you're going to have, of course, a repetition of sine theta times cosine of theta is sine theta cosine theta. Again, cosine theta is to give us the same, so it will be 2 sine theta cosine of theta, and then cosine times cosine would be cosine squared of theta. Now sine squared theta plus cosine squared of theta, we know this is equal to 1, and then we have plus 2 sine theta cosine of theta. So this part is equal to 1. Now I'm already from showing you the double angles to say 2 sine theta cosine theta is the same as sine 2 theta from the double angles. Okay, so this is already proven. Remember, try this sine theta plus theta, it will give you that. So we've proven now for this one. And then for D, which part looks complicated again? I feel it's still the first part. So 2 cosine theta. So you can actually pause the video and try it out. So if you are people who know mathematics here, you are going to say we have what? Call it difference of 2 squares. Okay, so feel free to pause the video. So I'll pick the left hand side since it looks more complicated. So I can still multiply this times that, and so on and so forth. So 2 cosine theta times that, we'll get to have 4 cosine squared of theta. Again, this times that, it will give us a minus. This times that will give us a positive, so they will be subtracted. That's why we're calling it the difference of 2 squares. And then 1 times negative 1 will just be like a minus 1. So I was calling it a difference of 2 squares. Okay, why was I calling it a difference of 2 squares? How can we simplify from this part going to that part? What should we do? we have cosine 2 theta. So cosine 2 theta, it means we'd have to have cosine squared of theta, and then have, okay, so I don't know what we're going to do here. Yeah, but let's try to observe what we have. So we have 2 cosine squared of theta there, and then we have cosine 2 theta there. Well, I don't know if, okay, let's try the right hand side now. I think the left hand side now has looked simplified because the difference of 2 squares. So the right hand side is equal to 2 cosine squared of theta plus cosine 2 theta. So let's try to plug in. So for 2 cosine squared of theta, we can, maybe let's start with the other side. 2 cosine squared of theta, and then cosine 2 theta is the same as cosine squared of theta minus sine squared of theta. This is coming from the double angle identities, where you have cosine theta plus theta. So cosine is selfish, cosine theta minus that. Okay, are we any step closer? So remember, we are only interested from the left hand side. We only have like cosine visible, so we need to do away with the sine. So I believe we can do something about it. So I believe we know that sine squared of theta is the same as 1 minus cosine squared of theta from the first identity. And then 2 cosine squared of theta plus cosine squared of theta minus a 1 plus cosine squared of theta. So I feel this part can go. Where, how are they going? Just how are they going? Let's clearly see what we've done here. So we are the negative here. Negative applies to the 1, it becomes a negative 1, and then the negative applies to the cosine squared of x, it becomes now a positive. Okay, they're actually becoming 1. So we have 2 cosine squared of theta, and then these will also be added. They will become 2 cosine squared of theta, and then we have a minus 1. I think this is now reducing to what we had. So these are also still like terms. So we now have 4 cosine squared of theta after adding, right? Minus a 1. Now I want to express it in terms of difference of 2 squares. So we can have 2 squared expressed representing 4, and then cosine squared of theta, and then 1 is presenting a squared as well. So at that point we have a difference of 2 squares. We can get every part of a square. So we have 2 cosine theta, and then we'll get 1 as a positive, and then the other one will be gotten as a negative. Okay, so difference of 2 squares. And then we can now conclude. So left hand side is equal to right hand side, and it's proven and all. So I'm trying to avoid the editing part because I just want you to see how you can approach these questions in reality. Because sometimes videos we try to edit and then try to make you look as though you're down, but these things you just have to like try. Okay. And then while we are on E, 1 minus cosine of x over 1 plus cosine of x is equal to tan squared, and then x over 2. So I don't know which part looks easier for you that you feel you can actually get to simplify. Okay, well, I feel the right hand side can be simplified. The left hand side for me looks like it's dark, so I'll try the right hand side. The right hand side becomes equal to tan squared x over 2. Now tan is the same as sine over cosine, so we're going to have sine squared sine squared of x over 2 divided by cosine squared of x over 2. Now where are we heading? We want to actually get a point where we only have like cosine. So what should we do about the first part? Now this is where now we got to, since we have pi over 2, and then we can see that on the other part we actually have like x, so it's like x over 2 is like the half angle. So this is now where the half angle formula comes into picture. Okay, so we've previously talked about the half angle formula, so I don't know if you're able to remember it. Remember we said it deals with only cosine as results. So if you have square of that for sine, it will be 1 minus cosine of theta over what? Now in this case we've got x over 2, so it will be x over what? 2. Now one thing that is clear for the sine one, that's why you have a negative. For the cosine you have like a positive. So dividing, so we are dividing. So dividing is the same as multiplying by reciprocal, but I'll start with division. So cosine squared of the half angle is equal to 1 plus cosine of that angle over 2 as well. So cosine maintains the sine for the half angle, sine changes the sign. It's 1 minus 1 plus over a 2. Don't forget that. So with that understanding, we know that division is the same as multiplying by reciprocal. So if we change by multiplication to multiplication, it becomes 2 over 1 plus cosine over x. Okay, so now the next step, the 2 can cancel, and then basically you're just going to have like 1 over minus cosine of x over 1 plus cosine of x. And then at that point we've already proven, so you can just add the statements. So left hand side equal to right hand side, or which is just equal to like left hand side, and then ends proven and all. So whenever you just see like the angle on one side is half, the other side the angle is like complete, just know that you're applying the half angle formula identity. So in summary, the half angle identity tells us that if you have sine squared of half an angle, it may be a over 2 x over 2, it is equal to 1 minus cosine the full angle over 2. For cosine, it is a positive 1 plus cosine of x over 2. These are the half angle identities. Okay, we're now on f. Sine 2x plus sine of x 1 plus cosine of 2x plus cosine of x. So I'll just start that. I'll start from there. This is of course the left hand side. We know the right hand side is going to be equal to tan of x. So how do you simplify this? This is something that looks so complicated and intimidating even to me. Let's try to see what we can do. So for sine double angle there, we know that it's going to be equal to, I believe you now know how to show it, so it will be 2 sine x cosine of x, and then plus sine x. For the denominator, we have 1 plus cosine will be, cosine double angle will be cosine squared of x minus sine squared of x. and then plus cosine of x. So if we want to get like if our goal is to get tan x, we expect that we need to have sine x remaining on top alone, and then on the bottom we should remain with cosine of x alone. So the issue now becomes, how do you eliminate the others? Okay, so let's try to see what we can do. Is there anything that we can actually cancel out at this point? Now one thing that we can clearly see is we know that 1 plus cosine squared of x, is it 1 plus 1 actually minus sine squared of x can be combined to give us what? That would be cosine squared of x. So for the top part, 1 to remain with sine of x. We can only remain with sine of x if we do what? If we factor out sine of x on top, we're going to remain with cosine of x plus 2 yeah. I'm just trying to like see what we can have. So if you factor out sine x on top, you're going to remain with, no, you're going to actually remain with 2 cosine of x for the first part, and then the other part will just be plus a 1 plus 1. Now the question is there any possibility that on the bottom we can like remain with, if we factor out cosine of x, we remain with also 2 cosine of x and then plus a 1? I think that is the question that we can have here. So that means we'll have to factor out like okay, let me try out some few things here. So we have 1 plus cosine squared of x. What if we tried substituting? Since 1 minus sine squared of x is like cosine squared of x, so we have cosine squared of x plus cosine squared of x, and then plus cosine of x. At this point we can factor out cosine of x, I believe. So this will become like 2. Will become 2. So in factoring out, you're going to factor out cosine of x. If you do factor out, okay, I think it has come out now. Okay, so combining 1 minus sine squared of x gives us cosine squared of x. So you have 2 sine of x cosine of x plus sine of x over that to give us cosine squared of x as well. So you are going to have 2 cosine squared of x plus cosine of x, because 1 minus that is cosine squared of x plus the one that is already there, they give us 2 of them. And then we can factor out now. For the top part, I can factor out the sine of x, since we know what we want, the sine x on top, and then we remain with 2 cosine of x plus 1. For the denominator, we're going to remain with like we factor out cosine of x, and then we remain with 2 cosine of x, and then plus like a 1. So this part will like just divide, and then we eventually remain with sine of x over cosine of x, sine of x over cosine of x, which is now equal to tan of x. So this is equal to the left hand side, which is now equal to the right hand side. So ends proven and all. Not very bad, right? And then we have a last one, which is g. So for g, what we have 1 over 1 minus sine of theta, and then 1 minus 1 plus sine theta, sine x. So what is our left hand side? So that's the difference of two squares. I don't know if it can come out. Let's try it out. So on the bottom, it's more like we have 1 minus, let's try it out. So common denominator is 1 minus sine x, 1 plus sine of x. So if we divide the first part into this part, we get the positive part, one with a positive sign, and then if we do the other opposite as well, we have a negative 1 now multiplying with it. If we divide that into this, we remain with a negative 1. So we have 1 minus sine of x. And then we have 1 plus sine of x minus 1 plus sine of x over the difference. So 1 minus sine of x, 1 plus sine of x. Okay, so at this point, what do you think we can do? So if you look at what we have, for the top part, 1 minus 1 can subtract. Sine x plus sine x will be 2 sine of x. And then the denominator, we have a difference of 2 squares. So that's the same as 1 minus sine squared of x. So some of you, if you've forgotten the difference of 2 squares, this is like a case where you have like x squared, and then you have like minus a 4. Okay, so that can be expressed as x minus 2, x plus 2. Even if you add 1 minus x squared, you can still express it as 1 minus x and then 1 plus x. So if you have this, you can take it to that. So I think that's what is happening there. So we can take it now. What do you think? What are we supposed to do for us to like move from there and get to that? So 1 minus sine squared of x is cosine squared of x. So we have 2 sine of x over cosine squared of x. And at this point, what should we do? Remember, we need to get tan and secant. So we have 2. So I'll divide by 1 cosine, since we'll split the cosine squared of x into 2, and then put the 1 there. I think it's now visible. Sine over cosine is 2 tan x, and then 1 over cosine is secant of x. Yes, I think we are done. So basically, identities are interesting. They help you to think fast and all, try and error kind of thing, but it's interesting. Okay, so if you're actually enjoying this video, you can actually have access to the full trigonometric solutions that will allow you to understand the topic fully. So the question 1 is there, the question 2 is there, the question 3 there, the question 4. Identities are also there. As you can see, question 6 and 7 are based on identities. Double angles are also there. Okay, so you'll be able to understand the half angle principles as well, looking at question 4. And then as we go to question 8, you'll also be able to understand how to go about it, how to solve trigonometric equations. Question 9 is also there, how to answer more equations. Question 10, dealing with sketching. Question 11, dealing with sketching. Question 12, dealing with sketching. Question 13, sketching as well. And then you also understand how to determine or evaluate these trigonometric kind of expressions, looking at question 14, 15, and also 16 as well. So you can have access to all these solutions by just registering. So you can visit our site, the link is in the description. From there you can also learn the topic from scratch, each basic concept step by step, and also access the solutions to this entire tutorial sheet.